Hi, this is the third video in the Unit 5 Review Guide series of videos. And in this video, we're going to talk about intermolecular and intramolecular forces and how they are related to the properties of ionic and covalent compounds. So our first question asks us, what properties do ionic compounds have that result from strong intramolecular forces acting in the compounds? Well, they are solid at room temperature. They have high melting points. And dissolve in water. They're not soluble in oil or any polar substance, non-polar substances. Okay, so they're not soluble in oil or any non-polar materials. They have high boiling points. And they are electrolytes. Which means they conduct electricity in water. So when they dissolve, they will separate into their ions. And because you have ions, you have charges, and moving charge is what is electricity. So they conduct electricity in water. What properties do covalent compounds have resulting from the intermolecular forces acting? They're often liquids or gases at room temperature because of it. They have low melting and boiling points. If we are talking polar covalent, they will dissolve in water. And they can be slightly conductive. They tend to have partial charges when they're polar. So depending on how strong those partial charges are, when they are dissolved in water, those partial charges can cause them to be slightly conductive, but not to the degree that an ionic compound is. How are properties of covalent compounds affected by the strength of the intermolecular forces acting between the compound's molecules? Things to consider: melting point, state of matter, room temperature, and viscosity. So if you have very strong intermolecular forces, you're going to have higher melting and boiling points because the attractions are going to keep those molecules closer to each other. A lot of times they're going to be solid because the molecules are being held close to each other in a more fixed state. Might be liquids, but the stronger the forces, the more likely they are to be solids, and they're going to have greater viscosities, meaning they're not going to pour easily. They're going to be very thick and flow very slowly. Okay, so that's when you have strong intermolecular forces, because those molecules are being held closer together. Different bond types experience different intra and intermolecular forces, which gives them different physical and chemical properties. Why can salt water conduct electricity? Salts are ionic. So they're ionic compounds composed of crystals. made of positive and negative ions. That separate in water and can conduct electricity. So the water itself is polar. It's going to surround these positive and negative ions. They move through the water. And again, moving charges are what creates electrical flow, so they can conduct electricity when they're dissolved. And that is a unique property of the ionic salts. So in the data table below, they give you some information. They give you 4 different compounds, and they give you information about whether they dissolve in oil or water, what their melting points are like, whether they conduct electricity, and they're going to ask you to figure out which are ionic, which are polar covalent, and which are nonpolar covalent.